Day 8. We are half done. Okay, so today we talked about DHCP, made sure people are clear, talked about lease and renewal. Some things you can look at. Look at the bindings to see how the IP is matched up with the device. And in our cases, we were using the switch to represent our, you could check, the switch for the DHCP. And we talked about different stateful, stateless, slack, and the different areas. If you're only slack, if you're slack and DHCP, the extra DHCP details like DNS wouldn't come from a regular slack. If you want to think of it that way, and then all DHCP between the devices. We talked about the addressing. I mentioned an example of a device that could just be slack because maybe there's an air gap between this network and all the other networks. Somebody can connect the other networks with their bring your own device. So we talked about the difference. 3560s, we had one issue which I'll have to check into. So we were able to use a couple 3560s. We were not able to get Jacob's to work, Jacob and Sam's. So what we did is we used Carter's. Well, Carter worked with Gage on this one, and Zach, David, and Jason here, and then Angie, we had Sam went to help this group, and Jacob went to help with this group. We were able to log into this router, and then from that router, you could telnet in, then you could telnet over to this router to get access to all the equipment from work server 2. So they did the configuration. I did an example with VLAN 80, but some of them did it on VLAN 10 or VLAN 20. They set up the DHCP, or they set up the slack and so forth, like the lab talked about in their multi-layer switch. Now we don't have PCs down here, but you can configure a VLAN on your layer 2 switch. You can do a configuration where you tell it to do auto config. You have to look up the syntax, and should get an address then from the IP6 addressing that you did on this switch. A couple things: you have to make sure the switch is doing both IP4 and doing IP6. You got to do that for both switches. Make sure that, and then you do the unicast routing. And that was one of the issues we had with one of them. The unicast routing was not an accepted command, so I'll have to do a little research on that. We finished up the day, okay, with first hop redundancy protocol. And the whole idea is you can create a virtual MAC and IP address by setting up one of these protocols between two routing devices, so that they talk to each other. All of your devices, you have a gateway and so forth, they all point to the virtual. Okay, so the virtual stays the same, and then these two devices talk to each other. So if one is set, like you set the priority, make one the primary one, configure it and make it the primary, so the traffic's going through that one. And then the other one would be in standby mode. So if something happens to, let's say, the primary, then the standby takes over. Now, there's a couple protocols they refer to that are Cisco proprietary, and then they talk to just some standardized protocol to do the same thing. Now, there are some protocols available that will allow you to load balance between your devices. For example, here we have a couple of routers. You can load balance between those routers, and then if one goes down, then the traffic just switches to the other. And it's the same deal. They're still all pointing to a virtual router that has MAC and IP. And there's a good packet tracer. It's a good example of the packet tracer in the lab of this work. And it's not hard to set this up with live equipment too, though we're not doing that, at least not now. Well, that's it.